Welcome to another exciting episode of AI Frontiers, where the latest advancements in artificial intelligence are brought to light. Today, the focus is on machine learning marvels, exploring 30 groundbreaking papers published on June 22, 2025. These works, sourced from the arXiv preprint server, highlight innovations shaping the future of AI and learning systems. Join in to uncover the trends, findings, and visionary ideas driving this field forward. Let's dive into a world where machines learn in ways previously unimaginable. Embark on a thrilling journey through the cutting edge of machine learning research. In this episode, key themes driving innovation from 30 newly published papers will be covered. Expect to discover jaw-dropping findings and the methodologies that power these advancements. Seminal works will be spotlighted, alongside discussions on future research directions. Stay tuned for insights that could redefine technology and society as a whole. This exploration promises to reveal the transformative potential of AI. To set the stage, let's understand what machine learning entails. At its core, it involves teaching computers to learn autonomously from data, identifying patterns and making predictions without explicit programming for every step. This technology powers everyday tools like voice assistants and recommendation systems, as well as transformative applications in self-driving cars, healthcare diagnostics, and climate modeling. Its ability to handle massive datasets at unprecedented speeds makes it indispensable. The 30 papers under review today push boundaries in efficiency, trustworthiness, and real-world impact, showcasing how this field continues to evolve and address complex challenges. These works highlight machine learning's role in solving problems beyond human capacity, setting the stage for deeper insights into specific research themes and breakthroughs that are redefining what's possible in artificial intelligence and beyond. One prominent theme in current machine learning research is self-supervised learning, a method designed to reduce reliance on costly labeled data. This approach enables models to learn directly from unlabeled inputs by predicting inherent structures or relationships within the data. A notable contribution in this area comes from Piccoli and colleagues, who apply self-supervised learning to polymer molecular graphs. Their technical innovation, known as Joint Embedding Predictive Architecture, focuses on autonomously predicting data relationships through shared embeddings. This is particularly relevant for data-scarce fields like material science, where obtaining labeled data is often expensive and time-consuming. By unlocking progress in such domains, self-supervised learning offers a pathway to faster, more accessible innovation, potentially transforming how new materials are discovered and developed for applications ranging from sustainable packaging to advanced engineering solutions. This theme exemplifies the field's push towards smarter, less resource-intensive learning strategies. Another critical focus in machine learning research is efficiency in training and deployment, addressing the computational challenges of increasingly large AI models, often with billions of parameters. The goal is to make these systems faster and more cost-effective, reducing the burden on hardware and energy resources. A standout work in this area is by Huang and colleagues, who introduce a decoupled learning framework called DeInfoReg for improved training throughput. Their approach breaks traditional long gradient flows into shorter, parallel segments, enabling faster processing across multiple GPUs. This technical advancement not only accelerates training but also democratizes access to AI development, allowing smaller labs or organizations with limited hardware to engage in cutting-edge research. Such innovations are pivotal in making powerful AI tools more accessible, ensuring that advancements are not confined to those with vast computational resources, and paving the way for broader participation in the AI revolution. Trust and robustness form another essential theme in machine learning, as ensuring AI systems are reliable and transparent is crucial for their adoption in critical applications. Interpretability is key here, enabling stakeholders to understand and validate model decisions, especially in high-stakes areas like healthcare. Research on steering vectors offers a promising method to enhance transparency by controlling specific reasoning behaviors in language models, making their decision-making processes clearer. Additionally, studies on robustness, such as those examining Byzantine attacks in federated learning, highlight the vulnerabilities of models to malicious interference and propose strategies to mitigate these risks. Such work is vital for securing systems where data privacy and trust are paramount. By addressing these challenges, research in this area ensures that AI can be confidently deployed in real-world scenarios, from medical diagnostics to security protocols, fostering greater trust among users and stakeholders alike. Turning to key findings, several breakthroughs from these papers stand out for their potential to shape the future of machine learning. Zahn and colleagues demonstrate remarkable efficiency with their Routing Mamba model, achieving performance comparable to much larger dense models while using significantly fewer active parameters. Research on Byzantine attacks reveals that these malicious updates pose a greater threat to model adaptability than traditional data poisoning, a critical insight for securing federated learning systems. Steering vectors, another highlight, allow for controllable reasoning in AI, such as expressing uncertainty, enhancing interpretability. Additionally, advancements in diffusion-based sampling accelerate processes like molecular design, which could revolutionize drug discovery. Finally, the Adaptive Spatio-Temporal Early Decision Model, or ASTER, excels in forecasting and resource-efficient decision-making, offering superior accuracy for applications like emergency response. These findings underscore the rapid progress in making AI more powerful, secure, and practical for diverse real-world uses, setting the foundation for transformative impacts across industries. The innovations in these papers are powered by a range of methodologies, each with distinct strengths and challenges. Self-supervised learning stands out for leveraging in-labeled data through pre-training tasks, reducing dependency on labeled sets, though it may miss nuanced patterns without supervision. Gradient-based optimization, such as stochastic gradient descent, remains a cornerstone for scaling deep models, despite risks like vanishing gradients. Reinforcement learning excels in decision-making via trial and error, but demands significant computational resources and struggles with sparse rewards. Graph neural networks are adept at modeling structured data, as seen in molecular graph applications, yet face scalability issues with large datasets and overfitting on smaller ones. Lastly, conformal prediction provides valuable uncertainty estimates with statistical guarantees, critical for fields like medical imaging, though it falters under data shifts. These tools form the backbone of modern machine learning, chosen based on the specific problem at hand, and their ongoing refinement continues to drive the field's remarkable progress and adaptability. Delving into specific works, the first spotlight falls on a paper by Piccoli and colleagues, titled Joint Embedding Predictive Architecture for Self-Supervised Pre-Training on Polymer Molecular Graphs, published in 2025. This research addresses the scarcity of labeled data in material science, a field where machine learning could accelerate the discovery of new materials like sustainable plastics or heat-resistant coatings. Their novel approach uses a self-supervised pre-training framework to learn from in-labeled molecular graph data, embedding structures into a shared space to predict relationships autonomously. After pre-training, fine-tuning on minimal labeled datasets yields impressive accuracy gains for tasks like predicting polymer properties. The impact is profound, potentially slashing the time and cost of material discovery for industries like aerospace and packaging. This work was selected for its innovative solution to data-starved domains, demonstrating how self-supervised learning can unlock progress where traditional methods fall short, and offering a blueprint for similar challenges in areas like drug design. The second highlighted paper, by Huang and colleagues, is titled DeInfoReg, a decoupled learning framework for better training throughput, published in 2025. This research tackles the persistent issue of vanishing gradients in deep network training, where updates become too small to drive meaningful learning, slowing progress significantly. Their solution, DeInfoReg, decouples long gradient flows into shorter, independent segments, akin to breaking a marathon into manageable sprints. Combined with a pipeline strategy for parallel processing across multiple GPUs, this approach achieves faster convergence, improved accuracy, and resilience to noise. The impact is substantial, enabling large-scale AI training on less powerful hardware and thus making advanced research accessible to smaller labs or startups. Selected for its role in breaking barriers to AI scalability, this work hints at a future where training bottlenecks are minimized, democratizing access to cutting-edge technology and fostering innovation across a wider range of contributors. The third paper in focus is by Zahn and colleagues, titled Routing Mamba, Scaling State Space Models with Mixture of Experts Projection, also from 2025. This research addresses the challenge of scaling state-space models, an alternative to transformers for handling long sequences like text or time series, without escalating computational costs. Their innovation, Routing Mamba, employs a sparse mixture of experts approach, where a router selectively activates a fraction of the model's parameters based on input type. Tested on language modeling tasks with models up to 1.3 billion active parameters out of a total 10 billion, and sequences up to 16,000 tokens, it matches dense model performance with over twice fewer active parameters and reduces operations by 23% in hybrid setups. This efficiency enables powerful AI on resource-limited devices, ideal for tasks like real-time speech analysis. Selected for redefining sustainable scaling, this work balances power and practicality, though it introduces added training complexity, marking a significant step toward deploying advanced AI in diverse, real-world settings. Looking toward the horizon, the future of machine learning appears both promising and complex, as reflected in these 30 papers. Hybrid methods that blend data-driven and model-based approaches are likely to gain traction, offering precision and flexibility for diverse tasks. Personalized AI, capable of adapting to individual users or resource constraints, could become a cornerstone of next-generation systems. Uncertainty quantification is expected to evolve into a standard feature, ensuring reliability across applications. Additionally, ethical AI research is poised to address pressing concerns like bias, fairness, and energy consumption, building on concepts like entropy-optimal learning. However, challenges persist, including data scarcity in niche domains, robustness against attacks or data shifts, and the ongoing issue of model transparency. Balancing innovation with responsibility will be critical as the field advances, shaping a future where AI's potential is harnessed ethically and effectively to address global needs and improve lives. Behind the scenes, this presentation was crafted with the aid of advanced AI tools to synthesize and structure the content. The synthesis process utilized models like GPT-Grok, specifically the Grok 3 version, to analyze and summarize the research. Text-to-speech elements were powered by Google's technology to ensure clear audio delivery for this podcast format. Image generation for visual slide concepts was supported by Grok, enhancing the illustrative aspects of the original deck. While human experts reviewed the content to maintain accuracy and relevance, minor oversights may still exist. All references to the original papers and resources are provided for transparency, encouraging further exploration by listeners who wish to delve deeper into specific studies or methodologies discussed in this episode. For those eager to stay updated on the latest in AI research, subscribing to AI Frontiers on YouTube is highly recommended. The channel delivers weekly insights into cutting-edge innovations and groundbreaking studies in artificial intelligence. Known as AI Frontiers, it serves as a hub for tech enthusiasts, researchers, and professionals seeking to explore the future of AI. The channel's mission is to bring forward-thinking content that inspires and informs. Listeners are encouraged to hit subscribe and join a vibrant, curious community dedicated to advancing knowledge and discussion around the transformative power of technology. Don't miss out on the opportunity to be part of this journey into the frontiers of AI and beyond. Thank you for joining this exploration of machine learning marvels on AI Frontiers. Reflecting on the breakthroughs discussed, from the innovative work of Piccoli and colleagues to other remarkable studies, it's clear that the field is brimming with potential. Listeners are invited to dive deeper into these papers through links provided in the YouTube show notes. Thoughts and reactions are welcome. What aspect of AI research excites you the most? In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.